Okay, so note that the CO2, when this reacts with water, it forms H2CO3. So this is the acid. This is the actual acid from the CO2 part. Okay, let's go on the next slide. Because it shows some equilibrium reactions as well as the equilibrium constant. So note that CO2 gas is soluble in water, so CO2 gas going to CO2 aqueous. Note that the equilibrium constant is 3 times 10 to the minus 5 at 37 degrees. So based on this equilibrium constant, 3 times 10 to the minus 5 is CO2 gas soluble in water. Okay, so what do we need to look at when we look at this number? Yeah, products over reactants. And is this a number big or small? Small. So does this tell us there's going to be more products or more reactants? So does that mean that CO2 is soluble in water? No. Yeah, so not much CO2 gas is going to dissolve in water. Now, the amount of CO2 which does dissolve in water, that's going to react with water to form H2CO3. The equilibrium constant for this reaction is 5 times 10 minus 3. Then the H2CO3 dissociates into its ions, H plus and HCO3 minus. The pKa is 3.8. And finally, the CO2 plus H2O goes to H plus and HCO3 minus. So what we want to do for this part is calculate K4. So in other words, what's the equilibrium constant for this reaction here? And I gave you a few choices. So K4 is equal to K1 plus K2 plus Ka, or K4 is equal to K1 times K2 times Ka, and you can read the rest. I'm going to try to choose all this. And then why did I choose 37 degrees for the temperature here? That's body temperature. Okay, so to give you a little hint on this one. If we have a reaction, say A plus B going to C, and we have C going to D, and we add these two reactions together, what do we get for the sum of those two reactions? Yeah, so we have A plus B going to D. Okay, so if we call this K1 and K2, we call this K3, how is K3 related to K1 and K2? K1 times K2 equals K3? Okay, so just to confirm that, we know that K1 is equal to C divided by A times B. And we know that K2 is equal to, let's see, B divided by C. So if K3 is equal to K1 times K2, does that give us what we're looking for? We have C divided by A times B times D divided by C. Is that equal to D divided by A times B? Yes. Yeah. Okay, so can we eliminate any of these choices from of these four? Yeah, so note that number one is K4 is equal to K1 plus K2 plus Ka. So can we eliminate this one based on what we just did over there? Yeah. And note that number 3 is K4 is equal to K2 plus Ka. So can we eliminate that one? Yeah. So it's either going to be number 2 or number 4, so which one do you think it is? Okay, so who thinks it's number 2? K4 equals K1 times K2 times Ka. Who thinks it's number 4? K4 equals K2 times Ka. So it looks like a few of you need more time. Okay, so look at the reactant. We have CO2 aqueous plus H2O liquid. And then the products are H plus aqueous plus HCO3 minus aqueous. Note that in reaction 1, it's CO2 gas going to CO2 aqueous. And then in reaction 2, it's CO2 aqueous plus H2O liquid going to H2CO3 aqueous. And then for reaction 3, it's H2CO3 aqueous going to H plus HCO3 minus. So to get reaction 4, which reactions are we adding together? Yeah, so to get reaction 4, we're adding together reaction 2 and reaction 3. So that means that our answer for K4 is equal to, yes, it's number 4. So it's K2 times Ka. Okay, so again, we're adding together reaction 2 plus reaction 3 to give us reaction 4. Therefore, K4 is equal to K2 times Ka. And in this case, the answer is 7.92 times 10 minus 7. Okay, now it turns out that the baking soda concentration in blood is 0.024 molar at a pH of 7.4. What I'd like you to do is to calculate the CO2 aqueous concentration in blood at that pH. So I gave you 3 choices how to do that. So you could either use K1 for reaction 1. And if you do that, CO2 aqueous is equal to 5.2 times 10 minus 3. Or choice number 2, you can use the HH equation. What's the HH equation? It's the. If you don't remember the names, that's okay. Do you remember what the equation actually is? Yeah, so the HH equation states that pH equals, yeah, so pH equals pKa plus the log of, yeah, the base over the acid.
Ask about the equation?
Yeah. Is it easier if we remember it as the H squared equation or the HH equation? Or does it matter? Okay, so choice number 2, use the Henderson-Hausbeck equation for reaction 2, or choice number 3, use the Henderson-Hausbeck equation for reaction 4. Okay, so know what you're given. You're given the pH. You're also given the HCO3 minus concentration. And you want to calculate the CO2 aqueous concentration. So going back to the Henderson-Hasselbalch equation, you're given the pH. You know what the pKa of either reaction 1 or 2 or 4 is? Or can you calculate it? And then do you know what will be the base in one of those reactions, and then what's the acid? Okay, so once you spend a minute, think about this. You can discuss this with the person sitting next to you. If you feel like it. Okay, so can it be choice number 1? Use K1 for reaction 1. So reaction 1 is this one here. So would you want to use this one to calculate the CO2 aqueous concentration? Given the information here? No. Because note that you're given the pH and you're given the HCO3 minus concentration, and then H plus and HCO3 minus are not in reaction 1, so you don't want to use this one. So for reaction 2, let's see, you have CO2 aqueous, you have H2O and H2CO3. Now is information on these 3 substances given in the statement here? No. So that means you want to use the Henderson-Hasselbalch equation for reaction 4. You want to calculate CO2 aqueous. You know what the H plus concentration is. That's based on pH. And you also know what the HCO3 minus concentration is. That's 0.024 molar. So confirm that the CO2 aqueous concentration is 1.2 times 10 to the minus 3. Okay, so in reaction 4, what substance is the acid? Pardon? Yeah, so this is our acid. What substance is the base? Yeah, so this is our base. So in our equation here, this is going to equal pKa plus the log of our base, which is the HCO3 minus, divided by the CO2 aqueous. The only thing we need to know is what pKa is. So what's the pKa of this reaction?
6.1.
And how do you get 6.1? Yeah, so we have pKa is equal to minus log of the Ka. And then Ka is equal to 7.92 times 10 minus 7. And that's equal to, what was it again? 6.1. Okay, so for our pKa, we can plug in 6.1. Okay, so in this equation, we know what the pH is. We know what pKa is. We know what HCO3 minus is, so let's solve for CO2. And do you get 1.2 times 10 minus 3?